So what is machine learning? So that's exactly what machine learning is. It's essentially AI that learns from data that you give it, and it improves the results, much like the human brain, right? You give it some information and it improves on what you're doing. It acquires knowledge, so to speak. And how does it do that? For example, something very simple, you give it a set of data, like Target wants to predict their sales. You traditionally use a statistical model. Instead of that, you could use basic machine learning algorithm. It's just another statistical model. That's the simplest way to think about it. Very simplistically, it's just a different way of running that same statistic, which is doing a better degree of correlation. Why? Because traditional statistical model would look at two variables, x and y axes, and then it'll try to correlate and draw a line between all those dots that you have between the x and y axis. Now here, you can have many dimensions, not just two x and y axes. You could have a z and n dimensions, how many ever, and then you can fit an entire surface, not just a line, and then you get a better outcome. So that's what basically machine learning is. But how do you then do that? And therefore the question, what is a neural network? So neural networks is essentially very similar to what was just said. It's a set of nodes that helps the computer find patterns. So in neural networks, trying to find what's different or not, and processing data at a very high speed, much like how you would do, and connecting neurons together or nodes, firing, and just like how your neurons fire within your brain, the neural networks fire within a node or not through what is called an activation function. And that's done through a series of things that are called weights and biases. A weight is how much value you should assign to the input, and a bias is just a delta, like a threshold. You're saying, oh, above this threshold. Oh, thresholds are low, add a threshold. Then another term that you're going to hear is large language model, or LLM. It's a model, and that model has been now fed language, English, or lots of information in English language, or maybe more languages. So the large language model came because someone took a giant corpus. So before GPT-3, they were trying to push a lot of information into it, but it wasn't enough. And this is one thing that is called the scaling laws of AI. Scaling laws of AI is how does AI get better and better and better over time. And therefore, AI models are different. And to get an AI model better, we need three things. We need data, we need computation, and model architecture, how your brain is structured, similarly how that AI model is structured. So over time, what has happened is how that brain model is, as in how that AI model is, has improved, has changed, has gotten better and better and better, till someone came up with this idea of the transformer model. So the transformer models were there, and that was GPT-1. That's why it was pre-trained transformer, generative pre-trained transformer, GPT-0, GPT-1, GPT-2. Until somebody said this transformer model is a great idea. It was a nice paper, it's a research paper, and we pushed it so far, but it's still not gotten to a place where we can really harness the power of AI. Someone has shown the possibility by taking the entire internet, feeding it into a transformer model, and saying that, okay, the model is amazing. And then the other term, when you have an agent, and if this agent is working on your behalf, you're kind of like you're the pilot of your life, and you're kind of giving the charge away to that agent to be your co-pilot. And when you hear that, people will sometimes in the software use it to mean an agent that writes software. People in business will use it to mean someone that creates a PowerPoint or whatever it is. But co-pilot in essence is using an agent that will do some of the stuff that you need for you, or a lot of stuff. It could be doing a lot, not just some. It could be going in, like any agent would, book a flight ticket for you or whatever else. In an enterprise context, it could, produce a recommendation for a customer, but do a lot more than that. Based on the recommendation, then go add it to their shopping cart, and then attach the coupon to it, and say, oh, this coupon should be attached. And then, then also look up their history if they allow that, and say, oh, but this is not good for you. Now you've got some basic grounding of these terms. Sure, these terms by themselves won't make you apply AI to your business. So understanding what does it mean for your business and understanding how you would apply it to your business is key.